Good morning, everyone. Welcome to yet another episode of Health Discourse with Sakshi and Sushant. And this is our ongoing cancer series. So, hi, Sushant. Good morning.
Good morning.
So, everyone knows that last time we spoke about, H2S pathways, which is related to the cancer metabolism, right? And this time we will be covering the energy efficiency metabolism. So I think most of you, I think people who are around cancer patients and cancer survivors, they must have seen the loss of energy and a lot of extensive fatigue throughout their cycle. Okay. So Sushant, please shed some light on this whole phenomenon and let us explain the audience about the energy metabolism.
Yeah. So today we're going to discuss about the cancer-specific cells energy metabolism and how the biological mechanisms make these cancer cells utilize glucose as a substrate and other energy fuel as substrate to fuel the growth and proliferation of cancer cells, right? And also a lot of reprogram metabolism which leads to metastasis, which is again the growth of uh, cancer cells and tumors, right? So before that, let us first discuss few of the you know terms which we will be using so that everyone is on the same page, right? So one is what we know, the glucose uptake is obviously the consumption of glucose, and glycolysis is again is the conversion of glucose into other lactate and fibrate, and again so this is one of the most important factors. Then we'll talk about the glycolytic metabolites, which is again produced uh, as a process of glycolysis, and again and we will also talk about the reactive oxidase species, the ROS role, right, and the role of antioxidants as well, right? And we are also going to discuss about, I think we discussed this during the last talk also when we discovered volatile sulfur compounds was the
Yes,
role of NAD plus, right?
NAD plus. Yes.
Yeah, right. So we are going to discuss all of these concepts. So first you have to understand, there is something called intercellular matrix, right? So this is how cells are attached and communicate with other cells, right? So during metastasis, it changes, right? And metastasis again, it's a growth of tumors and cells, right? So as to be very clear, so essentially inappropriate, intercellular matrix leads to, you know production of reactive oxygen species, which actually triggers cell death, what we call as anoikis, right? ENOIKIS, right? So essentially, this is another sort of death of cells, and probably, this has a very major role to play in case of uh, cancer cell. What happens is that through a process of there's increased glucose uptake and increased glycolysis. So essentially, glucose is converted to various glycolytic metabolites, right? Which will be measuring through our tests. So that is mostly is one is pentose phosphate pathway, serine synthesis, triglycerides pathway, then you know LDH is lactate dehydrogenase, right? So essentially, LDH is one of those pathways which convert glucose into which ferment glucose into lactate, right? And again, you have to understand that glucose is actually in normal cells. What happens is glucose is generally taken up by your you know glucose transporters, and they convert to pyruvate, and pyruvate again through a complex called PDH, it commits to TCA cycle, and that's how we produce ATP. So essentially, when there's a full maximal production of utilization of glucose in the presence of oxygen, what we call is mitochondria oxidative metabolism, right? So in that case, there's a lot of this energy produced. So one molecule of glucose actually produces 38 molecules of ATP, right? That's how we get energy, right? In case of, and that's a typical way of doing it, right? And in the case of cancer cells, what happens is that through a process called glycolysis, right? The glucose is actually converted to two things. One is these metabolites which I mentioned, glycolytic metabolites, which supports the growth of anabolic pathway, which is shunted into biosynthetic pathways, which leads to growth of cancer cells and tumors, right? And another part is probably, this is fermented on lactate, and again it is secreted, so it is not put to use to produce, to produce energy via glucose via mitochondrial respiration. And another factor is that, the oxidation of glucose, it means when the biological processes use the oxygen to convert glucose into ATP, right? There is, in case of the inappropriate ICM or detachment of cells, right? Basically, what happens is that, there is, we know that when the mitochondria produces energy, they also release reactive oxygen species, right, as a part of process, and they also release antioxidants that counter ROS, right? So that's how, so ROS, we know it causes oxidative stress and all of those things. So essentially, in case of normal cells, it is a normal process, right? You produce energy, you produce ROS, you secrete antioxidants, overexpression of antioxidants, which suppresses ROS, right? But again, here I'm going to tell you a few things which is really, really important from a cancer perspective, right? That in case of cancer cells, this detachment of cells, right? There's a lot of this ROS produced, right? Which actually lead to oxidative stress, and which leads to, which restores the cell sensitivity to this, what we call is NOKs, cell death NOKs, right? So it's again, and this ROS is actually anti-metastasis. It prevents the growth of cancer cells, right? By the fact that it actually, in terms of the cancer cells, it prevents the ROS, and that's how it proliferate these cells, because that energy is then not used to put to use to produce, actually to lead to cell growth, and that energy is used to produce ROS like antioxidant, provide energy, right? So essentially, it is imperative of cancer cells. So cancer cells have increased resistance to this this ROS induced cell death, right? Uh, this prevents from the ROS accumulation, the anti-metastasis activity, right? So essentially, the altered metabolism, what is happening is because of the epigenetic alterations in the oncogene and tumor suppressors, what we call as gene expression, which is again caused by inflammatory pathways, which we discussed last time. One pathway we discussed last time, right? So essentially, you know, this is altered or reprogrammed glucose metabolism is obviously put to use. I'm just repeating, but it's put to use to to produce these metabolites, which actually leads to cell proliferation, growth of tumors. It is fermented lactate, which is secreted from the body, is not put to use of mitochondrial metabolism, so not put to use of energy, right? So that is the basic concept of, in case of cancer cells, the energy is not energies of glucose does not reaches the mitochondria. It is not utilized by mitochondria to produce ATP. Rather, it is used to produce the metabolites and the lactate, which is used for cell fermentation, cell growth, and lactate fermentation, right? So essentially, uh, this is uh, this is something very, very basics to understand, right? ROS in case of cancer cells, right? They prevent ROS because obviously ROS means that mitochondria released. ROS here means the mitochondria released by, it's a byproduct of mitochondria producing energy, and again, that is something cancer cells try to prevent, right? Either by preventing glucose oxidation. Again, I'm using oxidation word because in case of energy production, a lot of these glucose is converted into ATP in the presence of oxygen. So it is oxidized, right? So in case of oxidation, right? So it prevents glucose oxidation, or it leads to overproduction of antioxidants, which suppresses ROS, right? So there's in case of cancer, there's a constitutively expressed antioxidant activity, right? Or there is a suppression of this glucose oxidation, right?
I have a question here, Sushant.
Yeah,
Since
yeah,
you have continuously mentioned that this increased antioxidant production is going to lead to that ROS depletion, right? So, I mean, antioxidants, as per my understanding, it was that, the more antioxidants you have through the nutrition, the better it is for you, right?
yeah,
And when
yeah.
we talk about the absorption of antioxidants, then that is altogether another thing. But
Yeah.
now here you are mentioning when there is an overproduction of antioxidants. So how is this overproduction
So,
characterized?
so let me repeat it, right? So essentially in a normal cells, what happens? You eat something, there's a glucose, it is taken up by glucose transported, it's converted to pyruvate, and again through the conversion process, pyruvate is converted into entire, it commits to your PDH complex, committed to TCA cycle, it is converted into TCA and citrate, right? So essentially that provides you energy that converts your glucose into ATP, right? That's a normal process. In this process, mitochondria releases reactive oxygen species. It also releases antioxidants to counter the reactive oxygen species, right? So essentially, when in case of, this is a normal process, right? In case of normal cells, when there is a detachment of a particular cell, of there is an inappropriate intercellular matrix. So intercellular matrix is a way where cells communicate or attach with other cells, right? So essentially, when there's an inappropriate thing, there is an production of ROS, which leads to cell death, right? And this production of ROS is an anti-metastasis activity, right? So when the mitochondrial ROS is being produced, it means that energy is not being utilized by cancer cell for its growth, right? Or for the fermentation of glucose into lactate. It is actually put to use to produce energy, and that's how cancer cell does not grow, right? So ideally, we need ROS to prevent that in case of cancer cells, right? And we need low level of antioxidant activity, right? So that this ROS, this byproduct of mitochondrial oxidation metabolism is actually and prevents the metastasis of the growth of the cancer cells, right? But that's like a fight between a good person, a bad person, right? So cancer cells are fighting with the normal cells, right? In this case, and they would make all the they will use all the tools they have at their disposal to suppress ROS, right? So again, glycolysis is a concept which we discussed. It converts glucose or ferment glucose into lactate, this is done by LDH, and then we may that's why when we under ORAONCO we measure the function or the activity of LDH, which is lactyl dehydrogenase, right? Which is the one which prevents glucose from going to mitochondria and convert into lactate, right? So again, you have to understand, one is preventing mitochondria from producing ROS. Other is using that glucose to shunt certain or put certain metabolites into the to support the anabolic growth into biosynthetic pathway that leads to the growth of tumor, right? So essentially, that's why we are told that in case of cancer, the excess sugar consumption is really bad, right? So this is one thing, right? And second thing is so are you clear with this, or probably I need to do you have
No,
any
that's
questions?
that's that's pretty clear to me, the whole mechanism. I think you can
Yeah.
continue.
Okay. So second thing is you must have heard of a lot of these supplements called NAT plus, right? And again, your glycolysis actually feeds on NAT plus. In case of cancer, NAT plus is really great in terms of longevity and everything, right? But when you have cellular senescence, or you have this inflammation, or you are moving towards cancer, right? NAD feeds cancer cells, right? This is generally told, right? So what happens is probably they feeds on NAT, and there's very limited supply of NAT. So when glycolysis has used its NAT, so essentially the lactate fermentation by LDH, it actually couples to oxidize NADH, which is again a byproduct of NADH converted into NAD plus converted to NADH. So it oxidizes NADH back into NAD plus, right? So that is one of the factor why lactate fermentation promotes cancer cells. So it leads to production of glycolysis, and glycolysis lead to production of intermediate metabolites, which further proliferates the growth of tumors in the cancer cells. So essentially, it facilitates the cell division during the cancer cell division, right? So essentially, it leads to development of more and more cancers and more tumor growth, right? So that is NAD. That's what you told. If you're progressing towards cancer, NAD is really bad, right? So essentially, it's not only about what we call is not only about only lactate. So lactate, the glycolysis could be lead to activate certain other pathways such as serine biosynthesis. Again, there is another metabolite which I discussed earlier during the when we started the discussion, right? So essentially, in this case, our last topic, if you remember, we talked about NAMPT, which is again which synthesizes nicotinamide, which is again 2 NAT plus, which is again sold as longevity supplement, right? But in case of this NAT plus, again this produces NAT plus, or NAT plus again feeds your glycolysis, and again it leads to the production of glycolytic metabolites, which leads to growth of cancer cells, right? So that is this is again another very important concept, that if you need to know whether you are developing cancer, because if you think because these most of the symptoms are asymptomatic, so you may end up taking NAT plus, thinking it is good for longevity, but if there are molecular pathways activating your movement towards cancer, probably NAT plus is further will speed up your cancer process, right? So again, you need to inhibit NAMPT again, which we had discussed last time. H2S also is something which NAMPT activates H2S, right? And which leads to inflammatory pathway, which triggers cancer, right? So that is one thing. Another thing important I'm going to discuss is PFK1, which is again an enzyme, right? This is called a pacemaker for glycolysis, right? So this is important you to understand this, that PFK, when in normal cells, what happens is basically as I mentioned, glucose taken by glucose transfer to pyruvate through PDH complex gets into your TCA cycle and produce ATP and citrate, right? Now, with citrate and ATP are the metabolites, which suppresses the PFK1 expression of PFK1, right? But in case of cancer cells, because these energy sources are not being put towards the production of ATP, right? So it leads to overactivation of PFK1, which leads to further glycolysis, which leads to further production of metabolites, which leads to further cancer cells, because it leads to growth of tumor, right? So this is another concept you need to understand. So everything is revolving around reprogramming of glucose metabolism, how glucose is put to use to produce these metabolites, which leads to cell proliferation and cell growth and tumor growth, and being used to put to fermentation into lactate rather than being put to produce energy, rather than put to. So the focus of cancer cells is always here to suppress ROS activity, right? Do whatever means to suppress ROS activity, right? And promote antioxidant activity, right? So in case of cancer cells, right, especially in lung cancer as well as in oral cancer, right, these antioxidants, right, are constitutively expressed. So I mean, it is overexpressed, right? So that the ROS production is contained. They control the ROS production. They control the glucose oxidation, either by glucose oxidation or by overexpression of antioxidants. They control the ROS. So they stop the anti-metastasis activity, right? So now metastasis, what it's again detachment of cancer cells from the primary site and translocating or repopulating to a secondary site. Survival during the circulation, local invasion. These are generally what is the concept of metastasis, right? And again, in this case, obviously the role of the antioxidants is important. The cancer cells make it best to suppress ROS, right? And also, I mentioned about PDH complex, which is again which converts pyruvate to TCA factor, right? And again, There's certain enzyme in case of cancer cells which suppresses this activity, right? Which suppresses the ROS, right? So ideally, everything, all the things which we have discussed right now, right, is mostly uh, focused on your, altered glucose metabolism, right?
Yes, that's correct. Yes.
Right?
So I
Yeah.
think Sushant, since I think you've explained it in a very simple way for all the in terms of not it. This is actually a bit of technical, but if we understand, it has a lot to do with the whole production of
So
cancer cells in the body.
these are technical terms in simple words, in simple words for every listener, so that they do not uh, get confused or get overwhelmed with this. In simple thing is whatever you eat, right, in a normal situation, right, it gets converted into glucose various processes, right? And again, glucose is taken by glucose transporters, glucose transport converted into pyruvate, pyruvate. So in simple words, glucose is then converted into ATP, which is the energy currency for your cells, right? So there's a process we discussed that all these energy sources are transported to mitochondria before it is oxidized, right? So this again transport, we know there are different mechanisms in place, right? Different. Someone needs CoQ10, someone needs vitamin B12, someone needs some other nutrient or transport carrier to transport this, and again, mitochondria converts it to ATP. That's a normal cycle. And that's how you get energy, right? Uh, in case of when there is a detachment of a cell, probably during the once the detachment is there, these cells are very very smart, so probably they will stop this sort of energy production at that time, right? And again, in case of this detachment, we generally produce reactive oxygen species, right? And which leads to cell death. But this ROS is actually something anti-metastasis, because again, ROS means your mitochondria is being put to use. It means the energy sources is not being put to use, not being put to ferment lactate or lead to growth of cancer cells and growth of tumor, right? So essentially, that is how they stimulate the glucose oxidation to make sure there is an oxidative stress, right? In simple words, right? Which prevents the metastasis activity, which is again the growth of cancer cells. But in case of cancer cells, there's actually mechanism where it is used to put to ferment lactate or used to produce certain byproducts. These byproducts fuel your anabolic support biosynthetic pathway that leads to production, that leads to growth of cells, right? And these are the basics of thing, and their mechanisms. So probably cancer cells could over express antioxidant activity, could suppress ROS, could lead to activation of PFK1, which is again one of the enzymes which exceeds the speed of glycolysis. And here glycolysis means the conversion of glucose into lactate, right? So again, lactate further uh, increase the availability of NAT plus. Again, NAT plus is something which uh, uh, is so again, this LDH enzyme which converts glucose into lactate. Lactates, this leads to oxidized NADH into NAD plus, which gives a lot of high NAD availability, which further leads to glycolysis, which further leads to lactate fermentation, right? And again, which further leads to cell growth, right? Cancer cell growth, right? And then we have this thing where it prevents the oxidation of glucose, right? So everything is revolving around the altered glucose
Glucose
metabolism.
metabolism. So what can we actually do to, prevent this glucose metabolism from alteration? Because what happens is our diet, our nutrition choices and supplements that are
Right.
prescribed sometimes by healthcare
Okay.
practitioners, or let's say you're taking an over the counter, sometimes
Mm.
they do have these impacts on the body, right? Like we mentioned about the NAD, if your this NAD can backfire in a lot of cases, like you have mentioned, right? So, I mean, what should be done in order to prevent these things?
Actually the biggest gap here is, first of all, we do not know we have cancer, right? Until
Hmm.
unless we are already in stage 3, stage 4. For assume, if a person has a cancer, right? He doesn't know there are molecular indications which is triggered alteration in genes, which has led to changes in gene expression, which is causing overexpression of oncogene or underexpression of tumor suppressors, right? So essentially, a lot of microbiome has a role to play. In oral cancer, obviously, microbiome has a role to play, right? But we do not know because these are never evident in any. There are no tests which can measure the signal before tumor develops, right? So they are the expression of these enzymatic pathways and the genes which underexpression of genes which can suppress tumor, overexpression of genes which can lead to oncogenes, which overexpression of oncogenes. So essentially, we do not know, and we may take up, or we are taking a lot of high carbohydrate meal, or probably we are taking these NAD supplements we are not aware of, right? Because there's altered cellular metabolism inside the body, which cannot be measured by any of the tests right now. And that is one of the reasons why, even if you have early stage of cancer, right, you can learn these things and you can change your nutrition to actually uh, improve the activity of tumor suppressors, right? You may not enter in the metastasis stage, but you may enter into cell growth and tumor growth stage and cell proliferation stage, right? So the thing is, we do not know this, and till the time we do PET scan and everything, we are already in stage 3, stage 4, right? So essentially, we have already lost the battle because we are knowingly and unknowingly feeding our cancer cells, right? With high level of glucose intake, NAT supplements, right? A lot of these things because we do not know, you know, the change in the metabolism inside our body, the change in glucose metabolism, right? So essentially, uh, that's why I've been mentioning this every time that the current set of tests for cancer, right, is even if they PET scan or their enzymatic pathway, which are detecting tumor is already in advanced stage, right? So by the time you have tumor, you're already feeding your cells to ferment to convert glucose into lactate, to convert glucose into uh, various pathways such as PPP, with this pentose phosphate pathway, serine pathway, overactivation of lactose dehydrogenase, right? Which is actually which ferment this thing, which further feeds NAT through various metabolic activities, right? Through certain enzyme like PFK1, which actually leads to further glycolysis. Glycolysis further leads to fermentation. So it's a vicious cycle, right? So essentially, you are not you are eating something and it is being fed, not fed to your mitochondria, but is being converted into certain anabolic pathways, which is feeding the growth of cancer cells, right? So so that's why I've been repeating this. Some things I'm repeating because uh, there are a lot of things which were technical and this is very difficult for a layman to understand. But from a simple layman's perspective, the benefit of detecting cancer at the earlier stages, that's why I mentioned always food is medicine. You can change your diet, right? So that not feed the cancer cells, not feed the growth of uh, tumor, not feed the growth of cancer cells, not ferment glucose into lactate, not which further can lead to further NAT plus further glycolysis. In fact, you can change your inflammatory pathways. You can suppress your uh, oncogenes and promote the activity of tumor suppressor genes to actually eliminate cancer before even it develops, right? So this is today's topic is really, really important from a perspective of layman understanding that that's why you need to understand whether you are progressing towards cancer. You should change your diet. You should know whether glucose is being put to use to produce energy or being used to feed cancer cells, right? And that's why I've kept it very, very initially technical because a lot of people will not understand reactive oxygen species. Again, it's a byproduct of your mitochondria producing energy, right? So that's why this is when they are producing energy, it is not put to use to cancer cells. And again, that's a cancer cell hate ROS, right? They love antioxidants is really good in terms of in terms of normal cells, but in case of cancer cells, antioxidants really, really harmful, right? So
So thank
this
you,
is
Sushant. I think that
yeah.
was a very intuitive discussion, and you have covered a lot of technical points here. And I'm sure our listeners will be able to grasp them slowly with time. But I think since we will be doing further talks, it is going to get provide them more clarity with these terminologies, right?
Yeah, and just to let everyone know who are listening to it, next Monday we're going to discuss about the protein fermentation levels, how it leads to progression of cancer, which again we are going to discuss about uh, polyamides production, ammonia production, right? Kedrine, tryptophan, a lot of these, right? Which is again produced by oral microbiome, microbes in your mouth, which when they ferment, a lot of amino acids you consume, right? Again, another reason to why a high protein diet may be harmful for your biology.
That's going to be a pretty interesting talk then, I'm guessing. So thank you again for your
Thank
time,
you.
and for all our listeners, thank you for listening to our talks time and again. Please do listen to other episodes. If you have not listened to the first episode, please first listen to the first episode and then hop on to the second episode of the cancer series. And thank you.
Thank you.